Hello everyone, welcome to our YouTube channel named The Cosmos. Today, we are back with another interesting video. In this video, we are going to tell you about the possibility of life on Jupiter's moon. Let's get started. But before starting, I would like to request all of you to subscribe to our YouTube channel and also hit the bell icon to get notified. I hope you'll enjoy the video. Grab your snacks and enjoy the video. So without any further delay, let's jump into the video. Since time immemorial, humans have wondered whether there is intelligent life elsewhere in the cosmos, as it is hard to conceive that we are alone in the vastness of the universe. However, for centuries, we've had only evidence that only the Earth supports life. But a groundbreaking discovery is about to change all of that. Scientists have finally discovered new signs of life on one of Jupiter's moons. Which of Jupiter's moons supports life? What type of life does it support? And what evidence do scientists have to join us as we dive into the exciting discovery of signs of life on Jupiter's moon? Jupiter is at its closest 365 million miles from the Earth, and at its furthest a whopping 601 million miles. Despite the massive distance, we have always been interested in what is going on around the planet. The largest of all the planets in the solar system, Jupiter shines brightly in the sky. Despite its distance, Venus is the only planet constantly brighter than the gas giant, though. At times, Mars will give it a run for its money. Part of this has to do with its size and composition, but the planet grows brighter and dimmer, depending on its distance from Earth. How long will it take you to get to Jupiter? You're interested enough to pay it a visit. The time it takes a spacecraft depends on a number of factors. The path of a craft often varies as it slingshots off of planets, moons, and even the sun to gain acceleration while using less fuel. For example, the Galileo spacecraft launched in October 1989 and took just over 6 years to reach the gas giant, arriving in December 1995. But the craft took a very circuitous route. Traveling a distance of 2.5 billion miles, it traveled around Venus, Earth, and the asteroid Gaspara to reach Jupiter. On the other hand, Voyager 1 took only 2 years to reach the gas giant. It launched on September 5, 1977, and made its closest approach on March 5, 1979. NASA achieved this by designing the Voyager mission to take advantage of an ideal layout of the outer planets. Another mission, the New Horizons, took a more direct path after its January 19, 2006 launch and had a flyby of Jupiter on February 28, 2007. On its way to Pluto and other dwarf planets, the travel time to Jupiter was just over 13 months. Jupiter takes 11.86 Earth years to complete one orbit of the Sun. As Earth travels around the Sun, we catch up with Jupiter once every 398.9 days, causing the gas giant to appear to travel backward. In the night sky, Jupiter has a large collection of moons. NASA says Jupiter has 53 named moons, while others are awaiting official names combined. Scientists now think Jupiter has 79 moons. There are many interesting moons orbiting the planet, but the ones of most scientific interest are the first 4 moons discovered beyond Earth, known as the Galilean satellites. The planet Jupiter's 4 largest moons are called the Galilean satellites, after Italian astronomer Galileo, who first observed them in 1610. These large moons, named Europa, Ganymede, and Callisto, are each a distinctive world. Io is the most volcanically active body in the solar system. The Io surface is covered by sulfur in different color forms. As Io travels in its slightly elliptical orbit, Jupiter's immense gravity causes tides on the solid surface that rise 300 feet or 100 meters high on Io, generating enough heat for volcanic activity and driving off any water. Ganymede is the largest moon in the solar system. In fact, it is larger than the planet Mercury. Ganymede is the only moon known to have its own internally generated magnetic field. Callisto's surface is extremely heavily cratered and ancient, a visible record of events from the early history of the solar system. However, the very few small craters on Callisto indicate a small degree of current surface activity. The 4th moon orbiting Jupiter is Europa, which you will hear more about in this video. The search for life outside of Earth has taken many forms. Mars, Our neighboring world looks like it was once habitable, perhaps to Venus, despite its current hellish conditions. But in recent years, scientific gazes have been drawn elsewhere about the moons of Jupiter. But first, what evidence do scientists look for when searching for life on other planets? Duran Youngblood, a specialist in life living in extreme conditions, and Dr. Paul Kendrick, specialist on the early evolution of life, explain what they are looking for. Water. Almost all the processes that make up life on Earth can be broken down into chemical reactions, and most of those reactions require a liquid to break down substances so they can move and interact freely. Liquid water is an essential requirement for life on Earth because it functions as a solvent. It is capable of dissolving substances and enabling key chemical reactions in animal, plant, and microbial cells. Many complex molecules are needed to perform the thousands of functions sustaining complex life. Carbon is the simple building block that organisms need to form organic compounds, such as proteins, carbohydrates, and fats. Carbon is one of the most abundant chemical elements on Earth and a major part of all living organisms. Therefore, one working hypothesis is that life on other planets might also be carbon-based. Nitrogen-carbon is a fundamental component of organic compounds, but it can't do it alone. The complex proteins required for life are built up from smaller compounds called amino acids, simple organic compounds that contain nitrogen. Nitrogen is also needed to make DNA and RNA that carry the genetic code for life on Earth. Many bacteria can convert nitrogen from the atmosphere into a form that is used in living cells. Other things scientists look for include phosphorus, sulfur, and location. The last item, location, determines the right distance from the sun or star which the planet or the other celestial body orbits Earth. For example, it falls into the Goldilocks zone, meaning it is just the right distance from the sun, not too hot or too cold to have liquid water on the surface. So what evidence of life have scientists found on Jupiter's moons? Much attention has been paid to Europa, one of the moons with a diameter of 3,100 kilometers. Europa is slightly smaller than the Earth's moon, as Europa orbits Jupiter around 718 million kilometers from the sun. The surface temperature never rises above -160 degrees Celsius. A new model from NASA scientists supports the theory that the interior ocean in Jupiter's moon Europa would be able to sustain life. In addition, they have calculated that this water, believed to be an ocean under the surface, could have been formed by the breakdown of water-containing minerals due to either tidal forces or radioactive decay. This work, which is not yet peer-reviewed, is presented the first time at the virtual Goldschmidt conference and may have implications for other moons in the solar system. Europa is one of the largest moons in the solar system since the flights of the Voyager and Galileo spacecraft. Scientists have held that the surface crust floats on a subsurface ocean. However, the origins and composition of this ocean have been unclear. The researchers based in NASA's Jet Propulsion Laboratory in California modeled geochemical reservoirs within the interior of Europa using data from the Galileo mission. Lead researcher Mohit Malkeni Dasani said they were able to model the composition and physical properties of the core silica layer and ocean. The team found that different minerals lose water and volatiles at different depths and temperatures. They added up these volatiles estimated to have been lost from the interior and found that they are consistent with the current ocean's predicted mass, meaning that they are probably present in the ocean. The researchers found that ocean worlds, such as Europa, can be formed by metamorphism. This means heating and increased pressure caused by early radioactive decay or later subsurface tidal movement would cause the breakdown of water-containing minerals and the release of the trapped water. They also found that this ocean would originally have been mildly acidic with high concentrations of carbon dioxide, calcium, and sulfate. They initially thought the ocean could still be rather sulfuric, but their simulations coupled with data from the Hubble Space Telescope showing chloride on Europa's surface suggests that the water most likely became chloride-rich. In other words, its composition became more like oceans on Earth. For this reason, the scientists concluded the ocean could be quite habitable for life. According to the scientists, Europa is one of our best chances of finding life in our solar system. NASA's Europa Clipper mission will launch in the next few years, and so these results could help the agency with the mission, which will investigate Europa's habitability. Their models suggested that the oceans in other moons, such as Europa's neighbor Ganymede and Saturn's moon Titan, may also have formed by similar processes. The researchers have now teamed up with groups in Nand and Prague to try to identify if seafloor volcanoes may have contributed to the evolution of the chloride-rich water on Europa. NASA has recently released new high-resolution photos of Europa showing possible exploration sites. Scientists are almost certain that beneath the Jovian moon's frozen surface is a salty ocean.